Hello guys, nice weather we're having today, huh?
Wrong. The sun is burning my eyes and I'm sweating so much, man. Look at this guy getting a heat stroke.
What the hell is going on here?
Let me explain. Climate change due to global warming is getting worse and worse. The temperature is rising due to greenhouse gas emissions, which come from overuse of non-renewable energy. Scientists estimate that we have about 6 years left to limit global warming to 1.5 degrees Celsius, or else by 2100, hundreds of millions dead. As aspiring architects, we have to design buildings that help to stop global warming, thus saving hundreds of millions of lives. The building sector is responsible for 40% of the global emissions. It is important to implement energy-saving strategies in buildings to ensure our future is not compromised. Many design strategies are already adopted to limit energy demand through energy savings, especially in European countries. Therefore, welcome to our very accurate analysis and overview of Powerhouse Brattørkaia, an energy-positive sustainable office building located in Trondheim, Norway. But first, we go through some energy-efficient strategies of the building that contribute to its energy-saving powers. Facade. Not one, not two, but triple glazed windows. Automated active shading blinds to block or direct daylight. Thick insulation. All of this helps minimize heat loss during winter and maximizes solar gains during summer, reducing the need for heating and cooling systems, saving energy in the long run. Lighting system. Energy efficient LED lighting. Automated lighting sensors which adjust brightness depending on daylight, or as they call it, liquid light trademark. Automated occupancy sensors to turn off the lights when not in use. HVAC system. Waste heat recovery system to preheat incoming fresh air. VRF heating system for precise control. Demand control system to adjust ventilation rates accordingly. Basically liquid light trademark, but for air, so liquid air trademark. Waste management. Waste separation into recyclables, compostables and non-recyclables. Waste is transferred to energy plants and converted into energy. Regular waste audits to ensure efficiency. All these systems reduce the energy consumption in the building. But the part we are focusing on is the topic of renewable energy generation, which is how Powerhouse Brattørkaia got its Net Positive Energy Building title and BREEAM Outstanding certification. There are 3 types of renewable energy generated by Powerhouse Brattørkaia: solar energy, geothermal energy, and hydro energy. Fire, earth, water. Now we just need air and we have the avatar. Solar energy is where a lot of the energy is generated from. The building has a sloped pentagonal roof to accommodate almost 3,000 meters square of solar panels. This maximizes the exposure to the sun throughout the day and seasons. The slope of the roof is carefully designed through solar study analysis. Solar panels produce maximum energy when placed perpendicular to the sun rays. Therefore, the steep 19-degree roof gives the optimal position to harvest enough energy to be net positive over its lifespan. By doing this, it generates about 450,000 kilowatt-hour per year, which is twice as much electricity it consumes daily. So not only is it powering itself, it is powering neighboring buildings and facilities with renewable energy, therefore earning its name Powerhouse. Get it? Because it's a house that creates power? Okay, moving on. The process is relatively simple. Photovoltaic solar panels, which are made of silicon cells, convert sunlight into electricity, just like plants need sunlight to survive. The electric current is then sent to the building for immediate use or stored in the battery storage. For Powerhouse Brattørkaia, it is sent to the local grid to power other buildings. Next up, geothermal energy, which is heat that is naturally generated by the earth. Our favorite powerhouse utilizes a ground source heat pump to extract heat from the ground. This covers about 85% of heating and 100% of cooling in the building. The system circulates a fluid to absorb heat from the ground in the winter and dissipate the heat in the summer. A more in-depth look at the GSHP pump system shows that it consists of a ground loop, heat pump, and a distribution system. The closed-loop configuration goes 350 meters deep with about 40 different boreholes. No need to tankers for cooling you down, Mr. Earth. So why is geothermal so good? Well, compared to traditional heating and cooling system, it saves 160,000 kilowatt-hour per year. The fluid in the loop that absorbs the ground heat is compressed by a heat pump. This causes it to raise its temperature enough until it can be used for space heating or hot water, thus negating the use of air conditioners and heaters. Splish Splash Hydro Energy is next. The strategic location of the powerhouse, being sandwiched between the sea and a river, gives its ability to utilize them for cooling and heating within the district energy system. Both the sea and the river contribute to the system. It works similarly to the geothermal system, but with a bit more complexity. The system is too nerdy for me, so I'll dumb it down. Sea water hot, give fluid. Fluid become gas and even hotter because compressor. Hot give building through condenser. Gas now back to fluid. People in building warm and happy. Repeat. So the point of using hydro energy is because seawater has stable temperature throughout the year. Therefore, in winter, it can pump heat from the ocean, while in summer, it uses seawater as a source for cold. And the most important thing is that it is emission-free and reliable all year round. From what we have seen in Powerhouse Brattørkaia, we can conclude that it is the future of sustainability. It is a wealth of inspiration on how to implement environment-saving technologies, being an office and a mini power plant at the same time. It demonstrates the benefits of renewable energy when used correctly and efficiently, reducing greenhouse gas emissions, cost savings, and energy security compared to unhealthy fossil fuels. This is particularly important in Malaysia, where renewable energy is not as popular. Solar panels, geothermal, and seawater heat pumps can all be implemented locally, but the problem only lies with the willingness of the people. After the completion of Powerhouse Brattørkaia, it has received the highest possible ranking by the world's leading sustainability assessment method, the BREEAM Outstanding certification, while also supporting the UNFCCC Paris Agreement that works to limit global temperature increase. The embodied energy of the building is 220,000 kilowatt-hour per year, and it is offset by the fact that it produces 500,000 kilowatt-hour per year, thus creating a surplus of energy for itself and other buildings. It is also referenced in many articles and reports for showcasing its power-saving abilities. Truly the epitome of energy-efficient architecture. Thanks for watching, and most importantly, remember to like, subscribe, and comment down below. What is your favorite energy-efficient building? Looking forward to seeing you in the next video.